I want to just take a moment to kind of explain what we mean by build caching here. There's always some confusion when I go to conferences and talk to folks in the community. Hey, what's the difference between a build cache and my dependency cache? Are they the same thing? Well, they're not the same thing, right? Build caching for Gradle and Maven, how it works is you're caching all the steps in your build process, all the tasks, all the goals, right? Whether they're test tasks or like surefire goals and whatnot, you're caching all those. And you got this local cache where a developer runs a build and it's everything that all these tasks and goals that are running, the inputs and outputs populate this local cache. So you're pushing and pulling from this local cache. And essentially it's, hey, if nothing has changed, don't rerun all the stuff that is already up to date, right? And that's how this works. And then this remote shared cache is doing this on a global level across with your team, right? So you have CI writing to this remote shared cache, and when developers come in to do that first build of the day or whatnot, hey, CI has built everything. Let me pull from CI, from this shared cache that CI has built, and then it populates my local cache every consecutive build. And because of this, CI also pushes and pulls from this kind of remote shared cache. So I want to shoot off another poll here of how familiar are you with build caching? Okay, so 16% don't know what the build cache is. Okay, well, I'm glad I got to explain that for a minute. We'll show it in action. And then 16 are not using the build cache, using the local build cache, 26%. And awesome, you have some folks here, using both. That's 37%. That's amazing. That's great. All right, let's talk more about build caching. So, Doron, for you guys, right, you have many projects, right, versus a monolith or a monorepo, right? You just turn on the build cache, everybody has it. How did you pull this off to kind of, set up the build cache for all your microservices?
Yeah, so as you said, we have many projects. Each of them is a separate Java project. Each of them is its own, basically it's a separate Gradle project. So we had to apply the Gradle Enterprise plugin in order to work with the build cache and with Gradle Enterprise. And we also had to configure the build cache. So we created a custom Gradle wrapper, which we asked all microservices to use. And in that Gradle wrapper, we actually applied the configuration, which is a common configuration for our build cache. And basically, once services use this Gradle wrapper, then they're set up to work against our central build cache server.
And I recall, right, as we were, my team and I were helping you kind of setting this up, you got some great wins. From your biggest wins, I guess, were from compile tasks and integration tests. And this is a great kind of segue to this next slide here on how well caching worked for integration tests. So I just want to take a moment to explain to the folks in the audience what we're looking at here. We're looking at the Gradle Enterprise Build Performance Dashboard. We're looking at all builds from the last 7 days. We're looking at CI builds. And with Gradle Enterprise, you could filter for, the different types of builds and CI jobs and whatnot. In this case, integration tests. And this is from Doron's actual project. You could see that build time is around 14 minutes. And this avoidance savings, they're saving around 2.5 minutes per build as far as remote build execution time goes. And all these bars here, each of them represents an integration test, and the gray bar is how much of this avoidance savings from the remote cache. So some of these, the high ones are in the 10 minutes, close to 10 minutes kind of range, right? And so this was great. You turned this on, you got some great cache hits, right? You're saving around 2 days with just build execution time this week. But you notice that, hey, as time went on, these numbers were not as great as they originally were. Oh, and even though they seem great to me right now, you notice that. So you there were some issues breaking cacheability, right?
Yeah.
And so how did you find these, right?
So first, let me just describe what we see here. So as you said, this is the performance dashboard of Gradle Enterprise, and we can see how the build cache is we can see how the build cache is utilized here. So the higher the bar, the better. The higher the bar, this means it basically shows how much time is saved for each build. So the result here is pretty good. I mean, we save on average 2 minutes and 30 seconds by using the build cache when we run builds with integration tests. But once I saw that, I already knew that we had better results in the past. So I monitor this performance dashboard often, like once or twice a week, sometimes more, sometimes less. And I saw that the cache started to get less utilized. So I was wondering what's happening. Something must have changed. And
we should talk what folks are seeing here. Folks, this is a tool that you have in build scans, right? A build scan is essentially a scan of your build, right? And here, Doron, basically you did a build diff or build comparison feature when you compare two build scans to kind of see what broke cacheability.
Yeah, right? so let me just So the reason I expect in this case, so the build cache, as you explained, caches the inputs and outputs of tasks. One of the tasks that work pretty well with it is the compilation tasks, compilation of the various modules. But in our case, we also got to utilize the build cache for integration tests, and that's because our CI runs integration tests once someone commits code before they merge the code. And once they have their code reviewed and they merge it, then a pipeline runs, and the pipeline runs integration tests again. So because the code that was there before the merge, once the code was committed, is usually the same as the code that is there when the pipeline runs after the merge, then we expect the cache to be utilized. We expect to see cache hits and not cache misses. So here, what I did, once I saw that we have cache misses, I went and used Gradle Enterprise to compare between the task that runs before the merge and the task that runs after the merge to see what's the difference, because I don't expect I expect them to be the same, that the inputs to be the same. As you can see, we're seeing here task inputs, and I'm comparing the task inputs of the task before the merge and after the merge, and I see that if you see a blue and green circles, it means that there is a difference, and the difference is in one of the jars that is basically an input to the integration tests. And without this tool, it would be very, very hard to actually find the difference, because there are hundreds of jars and other inputs like environment variables and all sort of stuff. And this really focuses on the single jar that is different. So what I realized actually is that this jar is actually something that we generate during our build before we run integration tests. And I looked at the two versions of the left one and the right one. It's actually two versions, like the blue and the green. And I saw that because we generate timestamps as part of the code that we generate inside this jar, the timestamp is obviously different for different builds, and that was the culprit. That was why the build cache could not be utilized. And to solve it, I just removed this timestamp. It was not necessary.
And Doron, this is just developers being ambitious, right? You can't blame them for this. This is just the shipping features, right, at large scale. These are the kind of problems they deal with. How often does stuff like this breaking cacheability happens? That you see.
So things change. Yeah, so things change all the time. Code is dynamic. Services are being developed and enhanced all the time. So things break. Things break pretty often. And in this case, it was because of actually we made a change in the code generation mechanism of ours, and we didn't even notice that a timestamp is generated. It's not something that you would expect to actually break anything.
Yeah.
But yeah, so it happens, and that's why it's important to have something that helps you actually find the root cause.
Yeah, and you fixed it, and the results were pretty amazing, right? We're looking at this build performance dashboard again, right? And now the build times have decreased. You got some of these bars or CI, these integration tests are saving around 30 something minutes here, right? Per build. These are the CI jobs, right? The integration tests, and you see the remote build cache average savings has doubled. This is to around almost close to 5 minutes of build execution time. And this is from our side. We always tell folks, hey, you need the right tools. You need to monitor cacheability because, hey, that 2.5 minutes that Doron and team got initially from the cache was great. And if he didn't monitor that, what would the difference be, right? So I ran some of these numbers. Doron and team run around 3,000 integration tests per week. And the remote cache was initially saving 2.5 minutes, right? And that's 125, CI compute resources, hours per week saved, right? And per year, it's 250 days, right? That's what it kind of comes out to. And just this fix, right, got them to 243 hours of saved CI execution time per week and 486 days, right? So this monitoring the cache, right, with this build performance dashboard, it really paid off for you guys in this case.
Yeah, I think the point is that just having the build cache, the build cache is great. It saves a lot of time because it can utilize the results of previous builds. But just having it without actually being able to debug problems or to see why the build cache is not really utilized all of the time. So it's not the best. You should be able to actually utilize your build cache, and you need a tool like Gradle Enterprise.
Yeah,
it helps a lot with that.
The story, folks, you got to visualize build times. You need a way to monitor cache hits and misses. There's a build scan tool out there that can help you with that, and of course, Doron and team use Gradle Enterprise. All right, let's go to the next topic of just keeping your CI pipeline performant, right? We're looking at the build performance dashboard again. All the builds in the last 7 days, CI jobs in the last 7 days. And this time we're viewing dependency download times, right? And it's giving us, hey, the average is 2 minutes, but something happened here. These blue bars are these CI jobs, and the dependency download time for some of these is around 26 minutes. So Doron, what happened here? What was the issue, and how did you?
Yeah, actually, so this is just an example of an issue. You always have issues, and when you work as part of a team, you start seeing what actually how it started. I started seeing in our internal Slack channel, people were writing that our pipelines got very slow. So what is happening? Can anyone check what's happening with the pipelines? Why are they so slow? We're waiting for them. So what I did, I went into this performance dashboard, and it shows various metrics. It shows the average build time. You can also see specific build times of specific tasks. Each bar basically is a build. And one of the metrics is dependency downloading. And what I noticed is there is a spike recently. So that's a big spike. So that probably explains why pipelines started to be so slow. And when I see that dependency downloading started to be so slow, I realized that that's probably because of something that has to do with the binary repository or the network connection to the binary repository. So so I pinged the guys that are maintaining our binary repository, and that turned out to be the case. There was something malfunctioning there, and once they fixed it, that solved the problem. So what this helped me with is just pinpointing where the slowness comes from.